But right now we're going to do this. We're going to get the one that got away. Treasure pop this done before the end of the day over.
It's got the same
All right.
rhythm and
All right.
Talking to you.
All right. Now what we're doing here is we're talking a little bit about some of this AC stuff, and so my question is, why should we cycle the AC clutch to begin with? Why do we cycle it? Why did we start building these things so we could cycle the AC clutch instead of just, a lot of the older vehicles that had the suction throttling valve on them, the POA valve, they used to run the compressor just all the time.
Burn up a lot.
Well, not really. I mean, they typically lasted pretty good. The Cadillac, the Cadillac's got this big long compressor on it, and it's got a suction throttling valve, and that actually is mounted in the suction line. And what we're going to do, that's what the suction throttling valve looks like. See that? You seen one of those before? You seen a suction throttling valve? In the 60s and 70s, the compressor ran all the time, and the AC control head was set to AC, or even defrost, to dehumidify the air. Now, on some luxury models, the compressors ran all the time. And what you had right here is you had on this fitting right here, your inlet from the evaporator suction fitting. It would go through there, and the outlet of the compressor, that arrow down there should be pointed out. You had an oil bleed port from the bottom of the evaporator, and then you had pressure equalization port to the expansion valve, and a system charging port. It was mounted on that thing. We've got, as a matter of fact, if you look out there, and I ought to have it in my hand to wave around, there's one laying out there on that wall by the front end pit that came off that Cadillac. Now, what we typically did when we were working on one of those kind of old systems, that is something that typically you're going to replace. That's what it looks like in the vehicle and all that. All right, so the POA valve works in conjunction with the expansion valve to drop high pressure warm liquid refrigerant to a low pressure cold liquid. What else do we have nowadays that does that? What else do we have that takes the high pressure liquid, in other words, your leak on the discharge line coming out of the air conditioner compressor, you're going through the condensers, turning it from a high pressure gas to a high pressure liquid that's hot. And if you cool that high pressure liquid down, there are some vehicles like the Sonata that has another way of doing that. They don't have a suction throttling valve on them, but they do have a 2-compartment condenser that's got the receiver dryer built on the end of it, and it's a subcooler, and it cools it down so that when that liquid refrigerant is going back up here to the evaporator, it's already cool. It's not going as hot liquid, it's going as cool liquid, and that's going to make the air conditioner work more efficiently, right? Okay, but preventing the evaporator from icing is what this is what an evaporator looks like when it turns into a block of ice, right there. Now the problem with that is what? You got no cooling, you got no airflow, you got big trouble.
You got a wet floorboard when it unthaws?
Yep, well, whenever it melts off of there, but wet floorboards, can happen for a couple of 3 reasons. Anyway, expansion valve only systems change the size of the liquid line orifice based on the temperature of the suction line as it leaves the evaporator. Now, so let me turn this back off again to get my laser out of my pocket. See this bulb right here and this line right here? That right there has absolutely got to be against that suction line, right? And so you pull this around there, you got it going against the suction line. There's some of them have got an adjusting screw and all that kind of stuff. Liquid refrigerant are coming in. Move that laser so that people don't get confused because it's a second-rate amateur. All right, and basically coming out of that orifice going into the evaporator, it basically gets colder and colder and colder down to 0 degrees Celsius. This is saturated vapor. All right, and then your remote sensor bulb is measuring that, and it's changing the size of this orifice going through there. And that's why we call the other one fixed orifice. There's a fan right there. And if you ever run into a situation where you've got an expansion valve, usually this will be clipped to that suction line with something, or it'll be taped to it with with some of that black sticky press tape stuff. And if that ever gets separated from that suction line, you're going to have issues and it's not going to work right. Now, the orifice tube replaced the expansion valve, typically. However, there are some orifice tubes that act like expansion valves, but there aren't very many of those around. I saw some like at the Max convention when I was up there. But you might notice all the different colors. See that? You got green, you got black, you got blue, and this is just a few of the colors. You also got white ones and everything else. It can mount in the liquid line, but it can be anywhere in that line. On some of your older Chevrolet pickup trucks, you got to take the grill off, and coming right out of the condenser Right there in front of the radiator, you've got that liquid line and that that orifice tube is right there. The problem with those is when you start trying to use wrenches to take them apart, usually the threads come with them. So we may as well go ahead and sell them a condenser, or tell them they may need one. You may need a condenser before you ever put a wrench on it. So you may need a condenser and you may need a liquid line, because a lot of the time these threads are galled right there. You know, does stainless steel make a better gall-free threaded part? It doesn't. You guys learned that on that Chevrolet truck you was trying to serve the transmission on. Those stupid stainless steel nuts they put on there was harder to get off than any kind of a regular steel nut you ever seen. I mean, they should have put some on there that were brass.
Or if they'd put like this is bolt with the stainless steel, obviously.
Well, stainless steel will gall to stainless steel too. They use that stuff out on the. I used to see them use that stuff out on the water when I was mechanicing down there in the oil patch. And that stuff out there, you get into salt air, that stainless steel is worse than regular steel, or is bad, to try to marry itself to whatever you got it screwed on to. It's bad news. Anyway, that orifice tube is really important. Sometimes you got to replace the entire line to replace the orifice tube, because it'll be right up in the middle of the line and it's made into it. And what they do is they stick it down through there, they crimp it so it can't go anywhere, and then they bend the line to shape it like it needs to go. And like on a Jeep Cherokee, if you want to replace the orifice tube, you will be replacing the entire line, that goes from the condenser to the evaporator.
They said the same thing on my Mustang. You had to replace the whole line. I went and bought just the orifice tube, and I took a screwdriver that's this long, and I took and cut, as a flathead screwdriver, and I took and cut a slotted notch on one side with high speed, and I straightened the line so the bend wasn't in anymore. And I run that screwdriver down up under the orifice tube and turn it over and pull it right back out with it.
Yep. Yeah, you can do it if you want to do that, but a lot of the times what happens if you're trying to, the kind of luck that I have, if I try to do that for a customer, whenever I try to straighten the line and put it back, I created a leak. You may or you may not. You know what I'm saying? So that's a sort of a hit and miss. And that's why they say they want you to replace the whole line, because a lot of times if you straighten the line and bend it back like it was, it's bad. But I mean, you can get away with stuff like that, As a matter of fact, if you wanted to get cocky about it, you could basically cut that line and put a place in there where an orifice tube could be replaced, with a fitting. Like if you cut a line the same size out of one that had an orifice tube spot, where it comes apart, you could do all kinds of patching and everything. And we've done some of that kind of stuff here, but typically orifice tube systems have low pressure cutout switches that cycle the compressor off when the low side pressure drops below a certain threshold, usually about 25 psi. And that protects the compressor, improves fuel economy, and prevents evaporator icing. Now, the reason we wanted to cycle the compressor off to begin with was so we'd get better fuel economy. We don't want the compressor running all the time. Now, am I going to get better fuel economy if I drive from here to Atlanta with my AC on max or norm? Anybody got any words to say about that, huh?
Probably not.
I'd say,
Don't make a difference.
Sir?
Probably don't make a difference.
Actually, it does.
I'd say norm, because it cuts on and off more than.
Actually, it cuts on and off less than norm than it does max. If you put it on max, you're re-air conditioning the same air inside the car, and the compressor will spend more time off than it will on, and you'll get better fuel economy on max than you will on norm.
I thought you like norm was like not max AC.
Norm is pulling air in from outside, is what it's doing. Basically, it's like vent, except you're air conditioning the vented air. So that's a little blurb you can hit with. It's one guy asked me, he says, if I put my car in neutral and I coast down the hill, will I get better fuel economy? What do you think? He's looking at his RPMs.
Because when you take
I mean,
it off, the
depends
gas
on it.
kills the injector.
Touch the injectors off. I said, you'll probably get worse gas mileage if you put it in neutral. He said, what for? And I said, the way the algorithm is written in that engine controller is that at a calculated pulse width of less than 1.2 milliseconds and an engine speed greater than 1200 RPM, the injectors are turned off. That's even true, usually, well, in a certain way on GDI engines, So it doesn't exactly turn them off, it does something else. And as vehicles downsized and engines got smaller, the feel of the C compressor cutting on and off is annoying. Now, I had this 83 Volkswagen Rabbit, and the 83 Volkswagen Rabbit came with a couple of switches on the injector pump. It was a diesel. And it was supposed to tell you when to shift by turning on this orange arrow, you know, whenever you had reached your optimum whatever. And
Mine
so
stays on all the time.
I didn't have any use for that, huh?
Mine stays on all the time.
Yeah, your shift light stays on. Well, that's basically supposed to help you get better fuel economy. Of course, that diesel Rabbit got 55 miles to the gallon, you know. But anyway, I'd be driving along this thing, and I noticed that when I had the air conditioner on, it was really difficult for that thing to dig out. Like I wanted to really go on. And so what I did was I took a relay and wired it up so the normally closed contacts on the relay were carrying the compressor clutch. And I let this little switch, it was supposed to tell that thing to turn on that light. I actually wired it up so that when I went to wide open throttle, it would energize the relay and drop the compressor out automatically. So if I went to wide open throttle, my compressor was out and I had me some power. Felt like you, on that diesel, it felt like you kicked it into light speed. Now, if you know how to set up one of those old diesels up like that, you can make that thing really cook and book anyway, you know, but one way or another. Okay, compressors got smaller and lighter. Now, this one over here, this Denso compressor is common on Asian makes, and as a matter of fact, you'll see it on like Ford 500s and stuff like that, which is sort of like a Volvo. But that, see the scroll right there, and you got your little valves in there. Now these pictures right here are some pictures I took at the Max convention as I walked past these booths where they had the cutaway compressors, so I took these pictures with my camera. This was from an article I wrote for Motor Age. That one right there, you might notice that this one over here on the right has got a swash plate that's fixed, and as that thing spins, those pistons go back and forth. So basically it's got pistons on both, I mean it's got sealing rings on both ends of that thing, and as this spins around, those pistons go back and forth, and that's where you're creating your compressor. That one right there basically is one of these, like we're going to talk about, that changes the attitude of that from being more like this to more like that. When you put that thing in the middle, you don't have as much compression going on. You got no clutch out here, but you do have little breakaway things and all that. That's a swash plate, and this is a wobble plate. Because this one changes, that one doesn't. Okay, you got that? Variable displacement compressor was born to keep passengers cool while reducing the load on the engine. No clutch necessary, but the pulley's designed to break away and freewheel if something locks up. You got a swash plate, a piston, and all that. There's some cute little, pictures that I put up there. All right, wobble plates versus swash plates. See the old compressors like what I was talking about earlier? That one there is actually frosted up and everything. That's one like that Cadillac's got on it that we work on sometimes. The Frigidaire A6 compressor had a fixed angle swash plate that wobbled back and forth to cause the 6 pistons inside to move their full stroke at all times. And the old compressors weighed more than 30 pounds and required a lot of energy for the engine to turn. All right, so today's variable displacement axial compressors. And the heart of these lighter and easier to turn compressors is the variable angle wobble plate. This is a better picture of that than I had earlier with higher resolution. That's a 7SBU16C. Some of these compressors are internally controlled and some are externally controlled. In other words, the wobble plate. And some of them have got an external control. Some of them are electronic, some of them are hydraulic or / pressure. And so the wobble plate's nearly 90 degrees. See how that thing is set up to wobble? This is basically a really simplified design. The angle changes the piston stroke, altering the compressor displacement. When it's like that, that piston's not even moving. All right, a single shaft with a brass bushing for the plate to angle back and forth kept the plate at the desired angle, controlled by the valve in the side or the back of the compressor. And if a variable displacement compressor's wobble plate gets stuck in a lower displacement position, cooling will be lousy, and both the high and low side pressures will be low, like you had a low charge or a bad compressor. See, so you can have a bad actuator that causes that. If the wobble plate gets stuck in a high displacement position, you'll have the symptom of a restricted or frozen evaporator. So that's what you got to look for right there. It's good to know that you got one of them things. Well, low charges and overcharges can emulate other problems. So your time ahead to go ahead and do a recovery and recharge with the right amount of refrigerant set a baseline. You ever remember, a lot of you guys, that if you tinkered with stuff at home, incidentally, if you don't have ESCO certification by the time you leave here, it's liable to make a serious impact. Because it's a $32,000 fine if you don't have ESCO certification, or the equivalent, and you're working on an air conditioner. However, if you're working on your buddy's air conditioner and no money changes hands and you're not venting refrigerant to the atmosphere, you don't have to have ESCO certification, but you can't charge them nothing. You can't even get a pack of pork chops. You know what I mean? If you're gonna charge for it, you gotta have certification.
What if he donates?
If you donate what?
If he like money? Yeah.
This is the, you know, don't wake your mother up because she's been sleeping all night and the kid says, what if the house is on fire? You're looking for a loophole. Don't start with me. After the recover recharge, if you don't see any spots freezing, which would indicate a restriction, and it appears the compressor is not pumping or not throttling back to prevent too much of the drop, then you probably got a compressor displacement problem. If the displacement drove electronic, you naturally would check that out prior to going as the compressor, and you can kind of do that with a scan tool. All right. Oh, by the way, the only way you can tell if one's got the right amount of refrigerant in it is to make sure you get all the refrigerant out and then charge it back up with the right amount. Just adding some is not a good plan. And, all right. Most technicians go with a second choice, a newer remanufactured compressor, if the compressor is noisy or inlet screen orifice tube screen reveals some nasty metal and debris. Now that's not really the inlet tube. Some of them have got a screen, and I've got a kit in there where you can put a screen in the suction side of the compressor so that it doesn't get trash in there out of the system. Like if you've had metal in there and you could try to flush it and you couldn't get it all out, you can add a screen in the suction side, because if there's anything that's going to come into the compressor, it's going to come in through that big suction line. And there's variable different size screens you can put in there with that tool. This particular one here is a little inlet screen that came off the back of a van that we worked on. And I took that picture. You might recognize that that's my thumb right there, because you can see so much of it, right? And this right here is a little mechanical valve that you can put in some of the ones that have a variable, you know, hydraulic. But if it's got metal and debris though, you're supposed to replace the compressor. You got to get all that stuff either filtered out or flushed out anyway. Some AC specialists might consider replacing the control valve if they can do it easily, but if they decide to go that route, it's smart to give your customer a heads up and say, we're going to try this, but we don't know if it's going to work or not. Like one time, whenever I had this lady came in and was saying, my speedometer on my Taurus is bouncing around all over the place. That's back when they had cables. And I had devised a way to take that speedometer apart and fix that so that it wouldn't do that. I knew how to take it apart, and there was a drop of oil I could put down there in one particular spot, and it would make them run really smooth. And she says, this is going to cost several $100s to replace the speedometer. And I said, well, I'll for an hour labor, I'll see if I can take this apart and fix it for you, but no guarantee. She said, okay. And I took it apart and I fixed it, and she was really happy. And that's not something just anybody could do, because I'm smarter than most people, okay? So
Mine's the gears in the transmission make mine do it.
Huh?
Mine's the little gears that hook to the transmission is doing.
Yeah, I'll make it bounce around.
So you change your flavor?
I didn't mean to talk smack about being smarter than most people, but hey, you know, some of us got it and some of us don't. They tell me I'm full of it. Okay, typical clutch bearing and coil weighs about as much as a laptop computer. So you subtract the weight of the pulley, and doing away with the clutch drops 2 or 3 pounds from the car. So the advantage of a consistent load, when you're talking about the variable compressor, comes into play when the clutch is gone, but a slight penalty in winter for a little more drag factors in. When you're not using it, you got a little bit of drag, but that ain't much. There has to be a protection mechanism, such as the shear pins, to let the accessory belt, you know, break off if something locks up. Electronic control of the variable displacement side of the compressor is more common. GM has adopted a CVC solenoid, and Toyota has done the same. Scan tool pins for the newer GM compressor display duty cycle percentage for the solenoid controlling the compressor displacement. All right, if you can't read the PID on your scanner, you can grab a digital multimeter with the duty cycle function and watch the percentage and see if it increases when you dial the temperature down on the control head. Of course, you're always going to be looking for a desired versus target, you know, and stuff like that too. The PID for the compressor displacement solenoid is displayed on the data stream in current, which corresponds with the average cycle time of the solenoid. And so if the pressure isn't matching the solenoid's commanded state, you wind up getting a code for that. And it's an input-output feedback loop, just like you see on a lot of this stuff. Now you got electric compressors for hybrids. They're now standard, but in 2005 and 2009, Ford Escape Mercury Mariner used a mechanical compressor And it actually helped keep the battery cool, so they had another evaporator, the whole system back there that did that. Some Hondas used a compressor that was 2/3 mechanical belt driven with the remaining rear third of the compressor being an orange cable high voltage. And you can see that one over there with the high voltage. You see orange wires going to that compressor, be aware of the fact that there may be high voltage there, like 144 volts, something like that. And so don't get all fired up and everything. On the early Fords and GM battery, belt alternator starter, it says, if you got a customer that complains of insufficient cooling, the usual suspects still apply. You just gotta, understand how the system works. Now see this thing right here? This right here is a great big old motor that is on one of these idle stop units right here. And that thing right there can fire that motor up by itself. This starts the engine. This engine has no starter on it. That thing right here is what starts it up. You pull up there on one of these Chevrolets, you let off, and it goes dead. Hit your foot on the gas like a golf cart, it starts the engine back up, it takes off. A big strong motor right there. Inside that motor, there is a commutator in there that does not have any copper winding in it. It's got a bunch of laminated plates stacked together. It's got aluminum poured around it, electrical grade aluminum. It's a brushless alternating current motor. Yeah. But anyway, in the econ mode, the ICE, the internal combustion engine, will enter idle stop. As the refrigerant warms up from lack of circulation, the evaporator temperature sensor signals the controls that the evaporator is getting too warm, and the PCM commands the engine to start up. So it can run if it wants to. The ICE restarts. If you put it on max, the engine runs all the time. And that's the way it is on a lot of these hybrid vehicles. If you put the AC on max, the engine never shuts off. It runs all the time. 12 volts is fine for an electric water pump, and some vehicles have got electric water pumps on them, so be aware of that. Not sufficient to provide power in an AC compressor because it takes so much power to pull an AC compressor. You see down in here, you got windings in there like a little hybrid motor, and you got this permanent magnet in the middle. If you see these hybrids, they'll typically have the windings around the outside where it's walking that magnetic field around and it's spinning this. All right. Hybrids supporting 100 or more volts are perfect candidates for the corporate average fuel economy stretching electric AC compressor. They can run with the internal combustion engine off if they're fully electric. You may hear a slight growling sound from them, whatever, because if the engine's not running, it's not masking the deal. Well, 3 and 4 pounds of R12 in some vehicles used to be common. We'd add a half a pound to get the AC back into action for spring. Those days are gone. A system with a lightweight heat exchanger like a new parallel flow condenser, use about a pound or less, and you got to have a J2788 machine to get all of the refrigerant out of those. See them little tiny holes right there? All right, and that's the end of the show. Does anybody got any questions or comments? Are you ready for tomorrow's pop test?
Sure.
I got a few questions.
Okay, turn this one in here. Well, you want me to give you the answers or something? You do not.
The amount of fuel is determined by what?
What do you think?
I mean, I don't know what it's asking.
Whenever you've got a fuel injection system, when you've got an electronic fuel injection system, what determines how much fuel it puts in
How
there?
much air is in this one?
The computer.
Based on, I mean, the computer has to know something.
How much air is
Based on the
in
gas pedal, how far you press the gas pedal.
I think it's how much air is in this one. Because the option is since it reads, it tells it how much fuel to put in.
How does it know how often to fire the injector?
Timing.
What about the crank sensor? The crank sensor is telling it how often to fire them. So have you ever been listening to the injectors on a car with your stethoscope and it goes click, 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 click while it's idling, and you give it gas and it goes click, 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 and it picks up faster. Now that's determining how many times they fire, but how wide, what the pulse width is, how much gas they put in there each time they click, is determined by modifications that come to them from the engine coolant temperature, the way you're moving the throttle, how fast you're moving the throttle, intake air temperature. See, all of that is a factor. Engine load is another factor from mass airflow or the MAP sensors. So basically, engine load, throttle action, and temperature of the air and the coolant determines how much fuel gets put in there. There you go. All right, who else has got a question?
True or false, always check for TSVs
What
prior
is
to
TSV?
service.
I would definitely
Yes.
always check for TSBs before I did anything. Because technical service bulletins are good, they are our friend.
Blank injection is used during idle and periods of no load.
Ah, anybody that was paying attention when we were in the GDI session last Thursday should know the answer to
I
that one.
put direct injection.
What's the two different kinds of injection that a direct injection system uses?
GDI and
TD.
No, GDI is, there's two different types, of
SIDI.
two different modes of injection.
is it SIDI or something like that. It was up on the board the other day.
Stratified and homogeneous. Got it?
So to be
When you're idling and when you're letting off, it's a stratified thing. And homogeneous is basically what, I mean, homogeneous injection has been around ever since carburetors and before, right? Basically, it's a homogeneous charge where it's not stratified, it goes pop, 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 pops several, shots of gas in there.
homogeneous mixture, that's just a mixing of something.
That means it's a mixture that's the same throughout, it's not firing in, and all that. All right,
When is an homogeneous mixture used?
under load, whenever you're normal driving.
Are you wanting to do the whole pop test? Pretty
Pretty much.
Well, I mean, I don't know.
He'll remember the stuff a little bit better.
Richard, you said the best way to depressurize was to cut off the fuel supply and run it till it runs out of gas, right?
That's
But
what I
you
said.
need to monitor the high rail pressure with your scan tool. Monitor the fuel rail pressure with your scan tool when you're doing that.
I said-
Crank it again and again and again so that it runs out of gas without any low fuel pressure, because the high pressure rail is not gonna replenish if there's no low pressure feeding that pump. But whenever it runs out of gas, you make darn sure you're watching it, because you can still have pressure in there.
I said shut off the fuel pump and run it out of gas.
Yeah, but make sure make sure you got your scan tool plugged in and you're watching that common rail pressure. That's real important.
Many GDI engines use special shaped blank to create desired turbulence and concentration.
A special shaped piston, right?
Bingo.
Piston heads.
You remember that?
80% and 20% of higher fuel economy and more torque. What was the third one?
What do you mean? In which question you talking about?
Named at least 3 advantages of gas direct injection.
What do you think?
Oh no, that's what I'm
High
asking.
pressure.
I got 2 of them, I just can't think of the third one.
Smaller fuel droplets. Is that one of the things you said?
No, 80 to 20% higher fuel economy and more torque.
I put better.
Well, we got smaller fuel droplets, so you got better combustion.
I put better fuel mileage, more horsepower with smaller engines, and can add and subtract fuel from just one cylinder.
Yeah, and you can also determine how much is put in there, when it's put in there, the timing of it and all, but you got smaller droplets too. You know what I mean? You're atomizing the fuel with a lot tinier droplets, and so you got better flame propagation and less, of a propensity to produce emissions to begin with.
So why did manufacturers change to gasoline direct injection?
Changes in government emission law, changes in fuel corporate average fuel economy rating, and increased diesel emission, soot, and NOx requirements.
Soot and NOx.
Yeah.